In this video, I'm going to show a practical demonstration of how to use SPIRE with Envoy in order to provide spiffy verifiable identity documents to my workloads. There are some prerequisites, but I've already got those boxes checked. The SPIRE server is up and running in EKS and is configured to use ACM PCA as its upstream authority or root CA to sign certificate requests. In addition to that, my nodes have been successfully attested based on the criteria that I configured, which was simply that they must be part of my cluster named Alpha. Finally, successful node attestation means the agents have received their spiffy IDs and they can now serve the workload API so that workloads can request and receive SVIDs, which brings us to the main focus of this walkthrough, using SPIRE with Envoy. There are two reasons why this model works really well. For starters, using a proxy decouples the workload identity management and configuration from our application source code, meaning application developers don't necessarily have to concern themselves with the cognitive load or the plumbing that goes into configuring this setup. Another positive implication is that the development lifecycle doesn't get impeded by all of the security configurations that go into this process. The second reason is that SPIRE implements the Secret Discovery Service API. This is also known as SDS, which some of you may be more familiar with. And this is an Envoy API used to fetch and maintain certificates and private keys. Using the SDS API, we can configure the Envoy proxies to communicate with the SPIRE agents on behalf of the applications to request and receive their spiffy verifiable identity documents. We can also fetch the spiffy trust bundle over the SDS API so that our Envoy proxies can validate the identities of peer workloads to verify whether or not they're part of the same trust domain. In this particular setup, I'm going to have a front or edge proxy that receives traffic from the external facing load balancer. The edge proxy is configured with different listeners, with each one listening for traffic that should be redirected to the path of a specific upstream destination, namely GraphQL, orders, and products. Each one of them is a microservice. I'll go through these three applications one at a time. GraphQL communicates with both orders and products so that it can aggregate them and serve the results as a response from a single endpoint. So the GraphQL Envoy proxy will be configured to have three listeners. The first listener is an inbound listener for traffic coming from the GraphQL Kubernetes service. That traffic will be sent to the Envoy proxy, which will in turn send the traffic to the GraphQL container in the same pod. In addition to this, the Envoy proxy will have two outbound listeners, which will be listening for traffic coming from the GraphQL container and should be sent to the services for orders and products, where their respective services will forward that traffic to the internal Envoy proxies. Next, let's look at the Orders API. The Orders API has two endpoints, one which lists orders and a second which lists orders and their respective products. Since it only makes requests to the Products API, it will have two listeners, one inbound and one outbound. Similar to GraphQL, the inbound listener will handle traffic coming from the Orders Kubernetes service and be sent to the Orders container. The outbound listener will listen for traffic destined for the Products API, so Envoy will send it to the appropriate destination, which will be the Products Kubernetes service. Finally, our Products application only serves a list of products and doesn't make any requests to other APIs, so it will have one listener for its inbound traffic. Now, it's important to understand the flow of traffic so that we're informed on how to validate the peers our services are going to be communicating with. One service, the Edge proxy, only has upstream servers that it communicates with. Two services, GraphQL and Orders, have both downstream clients and upstream servers, and one only has downstream clients, which is the Products API. That means we need to configure each proxy to request and receive a spiffy verifiable identity document from the SPIRE agent. Each proxy must present this document to its peer, as well as expect its peer, whether downstream or upstream, to present a similar certificate that can be validated. By setting this up, I'll have established trust, encryption, and mutual authentication between these peer applications. Now, let's take a look at this in action. All right, before walking through the code, I want to quickly show you my registration entries. 4 of them are for the workloads. You can see over here, Edge Proxy Service, GraphQL Service, Order Service, and Product Service. Each of these represents the spiffy IDs that those particular workloads are going to receive. I'm going to scroll right to the bottom, and over here we have the node registration entry. Now, I'm not going to get into the details of attestation and registration entries in this particular video, but you are welcome to look at the provided resources in the description below. I do, however, want it to be clear that this is a necessary step before your workloads can receive their workload identity documents. I'm going to switch over to my editor now. And let's take a look at the manifest for the Edge proxy and its different resources. Right at the top is the service account, and you could probably notice that the name of the service account for the Edge proxy correlates with the SPIFFE ID for this particular registration entry that will be tied to the SVID that the Edge proxy will receive. All right, so that's the service account. I'm scroll down a little bit and make the focus the service. And so you can see this is a load balancer service that will receive traffic from outside of the cluster, specifically listening on port 8081, and it will forward that traffic to a container running inside of my pod, which is also listening for traffic on 8081. And obviously these are arbitrary values, but sometimes making it the same is convenient. Let me scroll down even further, specifically to the deployment. And you can see over here that I am running a single container inside of my pod, and it is the Envoy proxy. And I'm mounting data from two volumes. You'll see over here, one is named Envoy config, the other is SPIRE agent socket. You might be wondering, what are these for? And this is a very important step. So the first one is to load the Envoy configuration file for the Edge proxy, which is stored in a config map, and we'll be taking a look at that just now. The other contains the Unix domain socket that workloads use to communicate with the SPIRE agents API. And so let me just scroll up a little bit further, and you'll notice over here that as an argument, I am specifically loading the envoy.yaml file, which is the data that will be taken from my configuration file so that my Envoy proxy can be configured to work specifically with all the settings that I would have provided in that file. And that gets loaded through this particular volume mount over here. Next, let's take a look at this Envoy configuration file that I was just referring to. As you can see, this data, specifically the envoy.yaml file, is stored inside a config map. And this is the same config map that I am referencing here in my deployment for the Envoy Edge proxy. And this is the data that will be referenced here. You can see the envoy.yaml file that will be used to load the specific configurations for the Edge proxy. Let me come back to the config map. Now, I'm going to try my best to avoid turning this into an Envoy tutorial by focusing on the parts that are relevant to the focus of this video. Now, the proxies can be configured statically or dynamically. I'm following a static approach, hence the property static resources, as you can see over here. And the two top level properties I'm going to focus on are listeners and clusters. If I scroll down slightly, you'll see that the clusters are listed down here. But let me come back up. Now, listeners are how Envoy receives requests or connections. For my Edge proxy, I have this single listener called service proxy. And this IP value over here is used to bind to any address. But I am specifying that the listener receives requests on port 8081. If you recall, this is the container port specified in the service and the deployment configs. I'm going to quickly come back here. Remember, both as the target port and, of course, the container port that our Envoy proxy is listening for traffic on. Now, I'm going to scroll down slightly over here to focus on the routing configurations for this particular listener. And I specify that a request that matches a specific prefix path or route should be forwarded to the relevant or appropriate upstream destination cluster. And if you're wondering what a cluster is in Envoy, a cluster is a group of similar upstream hosts that accept traffic. And I have 4 clusters that are listed below. But before I get to that, I just want you to see clearly here that when I receive a request to the specific Envoy Edge proxy that matches this prefix, it will be forwarded to the appropriate destination, the GraphQL cluster, the orders cluster, or the products cluster. Now that's only 3, so let's scroll down and see what the 4th one is. You can see here right at the top, this is my 4th cluster. It is the SPIRE agent. And the SPIRE agent cluster is the one that Envoy needs to communicate with in order for it to make requests and receive the SVID document. And you'll see that that is specified over here. If I scroll down slightly, you'll see that we have the GraphQL cluster. I scroll down even further, we have the orders cluster. And right at the bottom, we have the products cluster. But let's take a look at the GraphQL cluster and focus on that one, and that'll give us an idea for the rest of them. Okay, so the 3 clusters for the applications are very similar, different to the SPIRE agent cluster because of they have different roles that they're fulfilling. Okay, so the cluster for the SPIRE agent is essentially just so that we can make requests to the workload API in order to receive the relevant certificate. But let's take a look at the GraphQL one. All right, so you'll see over here that the traffic that gets sent to the GraphQL service is specifically sent to the Kubernetes service for this particular workload. And this is forwarded through to port 8002. Now I'm going to open up the GraphQL YAML just so you can see that that matches the GraphQL service over here. And this is the specific port that the GraphQL service is listening for traffic on. So that's where the traffic gets sent to. Now it's important to understand that when the GraphQL service receives that traffic, it will then in turn forward that traffic to the Envoy proxy, which in turn will send the traffic to the GraphQL container if the requesting peer is successfully validated. Now let's focus on the security aspect of this. So I'm going to scroll down slightly. And over here is where we can see our TLS or transport layer security configurations. And I want you to notice that this is specifically for the upstream context. So it deals with the TLS settings for communication with the upstream GraphQL Envoy proxy. And under the SDS secret configurations, remember this is the SDS API that I was referring to earlier. And under these configurations is where we specify the SVID certificate that should be fetched for the Edge proxy from the SPIRE agent. And you can see that I'm specifying the SPIFFE ID over here that will be received for this particular certificate. And under the SDS config, we have the relevant configurations for the gRPC API and the cluster that will be communicated with, which in this case is the SPIRE agent. And just under that, we have the validation context. And this is important because we don't only want to receive an SVID certificate, we also want to validate the upstream proxy. But in order to do that, I need the trust bundle. And so that is fetched under the validation context SDS secret configuration. And you'll notice that the configurations for the communication with the SPIRE agent over here is similar to what we specified over here for fetching the certificate, because this communication is the same. It's with the SPIRE agent and specifically the workload API, both to fetch the certificate, and then down here it is to fetch the SPIFFE trust bundle. And we need that so that we can be able to verify the SPIFFE IDs of the certificates that peer services are going to receive. In this case, I'm specifically dealing with the GraphQL upstream service. And in addition to that, I'm also specifying that the certificate that the GraphQL service should presents to me should match this exact SPIFFE ID in order for communication to work out. All right, so now I'm going to scroll down and just quickly show you that it is the same case even for the others. Orders, as you can see over here, in the same way, I am specifying the SPIFFE ID for the Edge proxy and the means by which the certificate will be received. And in addition to that, I'm also validating the certificate for the upstream server, which is orders in this case. And I say that the SPIFFE ID for orders should match this exact URI. And this is repeated as well for products. And for each of them, remember, this is where I specify the trust bundle that should be received. And you can see my trust domain over here is outlier.org. So that pattern is repeated for each of these. Now, in the case of GraphQL, orders, and products, I also specify that I want to validate the client certificate. So I have a property over here, require client certificate, set to true. So this is necessary for mutual authentication. Remember, in the case of the Edge proxy, it is sending requests to upstream servers. But in the case of GraphQL and orders, they are not only going to be sending requests to upstream servers, they also receive client requests. And that's the same with products as well. It receives a client request. And so I'm specifying here that I want to receive a certificate from the client. And then in addition to that, I specify that that client certificate should match a specific SPIFFE ID. So if I scroll down over here, you'll be able to see that the certificate should match the SPIFFE ID for this particular URI, which you'll notice is the SPIFFE ID that the Edge proxy receives. And just as I did before with the, just as I showed with before with the Edge proxy, this is repeated with the different services as well. So this way we get to validate both upstream servers as well as downstream servers. Now, that's enough talk. Let's take a look at what this actually looks like and what the impact would be if we were to change some of these settings. All right, so the first thing to do is to ensure that everything works as expected. And by that, I mean that there's mutual authentication between each of the Envoy proxies. I'm going to test out this query over here, and you can see that the GraphQL API is successfully able to reach orders. And in turn, orders is able to reach product and fetch that data, as you can see over there. And right at the bottom, we've got another query which just lists all the products. So that's good. That means that there is communication between the GraphQL API, orders, and products. And this is enabled by successful validation of the certificates that they are presenting to each other. And in addition to that, those certificates that are presented have the correct or matching SPIFFE IDs that each of the peer services expects to see. And over here, I am specifically fetching just the orders list. And if I just refresh that, you can see that this is working properly as well. And remember, the steps that it takes to get there is first the Envoy proxy, the Edge proxy gets hit first. The Edge proxy then in turn sends this traffic to the orders cluster. Over here, I have orders listed with their specific products in case you want to see what the difference is between these particular two. And this is also working just fine. And then lastly, we've just got the list of products. But what happens if I change the name of the SPIFFE ID for the Edge proxy? When I do that, I shouldn't be able to reach any of these upstream clusters or upstream destinations because of a failure of the Edge proxy to present the expected certificate. So I'm going to switch back to my code editor. And just so it's fresh or top of mind for you, I'm going to come to the config map for GraphQL and just remind you that it expects to see a client certificate. Remember, you can see this is set to true, but not only is it expecting a certificate, it is expecting a certificate from this trust domain and that it should match this specific SPIFFE ID. And that's the case with orders as well. I'm going to scroll down slightly till I get to that specific point. And you can see here as well, require client certificate is set to true for orders, and orders expects to see certificates that have matching SPIFFE IDs either for this Edge proxy SPIFFE ID or this GraphQL SPIFFE ID. Now, I'm specifically going to be dealing with the Edge proxy one, and that is the same case as well with products. Let me scroll down, and you can see require client certificate is set to true. and these are the SPIFFE IDs that it expects to see. So we're going to mess with the edge proxy SPIFFE ID, and we should not be able to reach any of these. So instead of edge, and just so you can see this quickly, now I'm in the config map for the edge envoy config. Make sure that that is clear. Scroll down, and then under clusters, I'm going to start off with GraphQL, and I'm going to change this to hedge. And I'm going to do the same thing for orders. And lastly, for products. I'm going to come to my terminal. And I'm going to apply these changes to the existing config map. Now, after I've done that, I will have to restart the edge proxy pod so that it loads the new configuration data. And I'm just going to use K9S for that. Come here. Great, so it started up. We've got the new configurations. We could verify this just by going to the config maps, making sure that this has been applied. I'm just going to describe that, the edge envoy config. Scroll down. And as you can see over there, we've got hedge proxy service account instead of edge proxy service account. And that is not what our upstream servers are expecting. So if I come back to my browser, I'm going to refresh and see if I'm able to reach GraphQL. And you can see over there, upstream connection error. And you can see that the secret is not supplied by SDS. So we're getting a TLS error. And it'll be the case for each one of them, because that is the wrong SPIFFE ID for that particular service. So let's switch back. Let's correct this. Save that. And once again, I'm going to apply these changes. Head back here, restart the proxy. And now if I refresh, we see that there is successful communication. And that's the case with each one of them. And this would be the exact same situation if I was to mess with one of the upstream servers. For example, orders. So I'm going to come to the orders config map, and I'm going to mess with the communication between GraphQL and orders specifically. So I will come to the GraphQL config map actually, and I am going to head to the cluster for orders. There we go. And you can see over here that the upstream validation is expecting a SPIFFE ID that matches this particular value. So I am going to get rid of the S and just change it to order service account. And just like I did with the edge proxy, I'm going to restart the GraphQL pod. Okay, so that is running. Now, bear in mind that I should still see this specific page once I refresh, because there is no breakdown in communication between the edge proxy and the GraphQL proxy. However, this request over here should fail because GraphQL will no longer be able to speak to orders, but I should be able to see a list of products right at the bottom because there's no issues between GraphQL and products. So let's check that out. There we go. You see, and under the errors, request failed with the status code 503, and that is because of the wrong SPIFFE ID that is presented by the orders service, because GraphQL is expecting one that doesn't have an S at the end. It's expecting order service account in the suffix, whereas the certificate presented by orders API actually is a plural. But like I said, right at the bottom, we've got products, which has successfully listed because there's no breakdown in communication over there because of mutual authentication between the Envoy proxies. And so if I was to make that change, then everything will go back to normal and work again. And there you have it. Everything has been restored. So that shows that our mutual authentication based on SPIFFE IDs is working as expected. And I hope that you found that helpful. Thanks a lot for taking the time to watch this. Go ahead and try it out in your own environments. And as usual, please let us know if you have any feedback. And as usual, stay tuned for more.